Hi everyone, this is Jai, your instructor for ComputerNetworks. The topic that we are going to discuss is router structure. As we know, the main responsibility of the network layer is to deliver the data from source device to destination device. And to deliver the data, the network layer has a responsibility to select the best path so that the data can be delivered to the destination as fast as possible. And to perform this job, there are some special devices which are called as routers. So router will receive the packet, and after receiving it will analyze and it will select the best path among all the available paths, and it will deliver data to destination. Now we are going to see what is router and what's inside it. So let's see. So in the router, there are mainly some blocks are there. The first block is high speed switching fabric. Then there is a routing processor. Then there are some input ports and there are some output ports. So this is the basic diagram of the router. These many components will be there in any router. So router is having some processor. Why it is having some processor? Because it will receive data. After receiving data, it will analyze the packet. To analyze the packet, there should be some processor available in the hardware. Input ports are used to receive data and output port are used to send data. And switching fabric is hardware using which the data can be moved from the input ports to output ports. So let's see what is inside the input port. The first block in the input port is the line termination. Now what is the line termination? Using this block, router can receive the signal. Signal can be in form of electromagnetic waves or in the form of voltage levels. So if the router is connected wireless, then the received signal in this block will be in the form of electromagnetic waves. But if router is connected wired, then signals are in the form of voltage levels. And this block is generally situated in the physical layer. After that, the next block is called link layer protocol. And this block is situated in the data link layer. And when the signals are received in the line termination, the link layer will analyze the signal. It will check that the received signal is having proper MAC address or not. It will also check that received signal contains any error or not. So all the responsibilities regarding to link layer will be performed in the link layer protocol. And the next block is lookup and forwarding and queuing. Now what is the function of this block? In the receiving side of the router, there will be so many packets which are arriving at very high rate. Router has a responsibility to check each and every packet as fast as possible so that maximum number of packets can be transferred from the input port to output port. So that router must have a powerful processor. If router does not have any powerful processor, and if so many packets are arriving at very high rate, they will be queued in the block. And when so many packets are queued, and if it is greater than the memory of the router, then packets has to drop. Now let's see what is switch fabric. So generally there are three major types of switch fabrics. The first one is called memory, the second one is called bus, and the third one is called interconnection network. Let's see one by one. In this block, the switching fabric is used in the form of memory. So input port will receive the packet, and after receiving the packet, input port will store that packet into memory. And output port will take that packet from the memory. So you can clearly understand that this method is totally dependent on the speed of the memory. So it is totally dependent on the speed of the memory. If the memory is having very high speed, then data can be transferred from the input port to output port as fast as possible. But if the memory is slow, then it will take more time. So that is why it is said that the speed is limited by the memory bandwidth, means the speed of the reading and writing. The next type is the switching via bus. Now what is bus? Bus is nothing but a simply group of wires. So size of the bus can be 8 bits, 16 bits, etc. Right? So you can see that when the packets are received using the input port, it will be transferred to the bus, and using the bus, the packet can be transferred to the output port. The switching speed is limited by the bus bandwidth. If the bandwidth of the bus is limited, then it will take more time to transfer data from the input port to output port. If the bus is having very high speed, in that case, it will take very fast and will take very less amount of time to transfer the data from the input port to output port. Now let's see the switching using the interconnection. Now you can see that the input and the output port are connected using 3x3 crossbar or 8x8 multi-stage switch. So when packets are received, they will be divided and they are transferred from the input port to output port. So there is a dedicated line between each input and output port. You can see that each input port is connected to all output ports, and that is true for output port 2. Each output port is connected to all the input ports. So the packets will select the proper path from the input port to output port, and then that way the data will be moved from the input port to output port. Now let's see what is queuing. As you can see in this figure, in the first input port, the router is having two packets, which is red and blue. And in the last input port, the router is having again two packets, which is red and green. But these two red packets should be forwarded to the first output port. The data from the first input port and the third input port will not be transferred at the same time to the first output port, and that will create queuing at the input side. So there are many situations in which the packets at the input side will be queued up. So the first situation can be if the processing power is very less of the router. In that case, it will take more time to analyze the data and all the packets will be queued up at the input port. If the switching fabric is slow, or if more than one packets are trying to reach at the one port of the output, in that case it will also create the queuing at the input side. Now let's see what's inside the output port. So the first block is called as datagram buffer. The second block is called link layer protocol, and the third one is the line termination. Again, the things that we have seen in the input port, the same things are present at the output port. The first is the datagram buffer. So packets will be received from the switching fabric are stored here. Then there is a link layer. So when those packets are passed to the link layer, net address are added. Then again some extra data are added so that at the receiver side, the receiver can analyze whether the packet contains any error or not. And there is a line termination. In that block, the packets are converted into electromagnetic signals or voltage levels. So that is dependent on what type of router it is. If it is wireless, then they are converted into electromagnetic waves, otherwise in the form of voltage levels. Again, at the output port, the router will face some queue, and that is called buffering. Now why the output port is facing some queue? Because if router is transferring data from the input port to output port at very high rate, and the link that router is sending data to is having very low speed, in that case all the packets will be queued up at the datagram buffer. And one solution to that is that we can schedule all the packets according to priority. So there are generally four types of packet scheduling. The first one is called the first come first served. Then the scheduling can be in the base of priority, then it can be in the base of round robin, or in the form of weighted fair queuing. And this is it for today's session. If you have any doubt, you can ask me in the comment section. Thank you so much.